Okay. All right, so we talked about latitude on Friday. Remember that latitude are the parallel lines that run around the globe, and they are measured as an angle from the center of the Earth. Latitude lines are spaced out evenly, so every latitude line is equidistant from each other. Longitude is a little bit different. So it is another angle that is measured, but it is measured from a reference line rather than the center of the Earth. So there is no equator running north and south, so they had to come up with a line that they could use as a reference line. This line is called the prime meridian, and they have designated that as 0 degrees longitude. It runs through Greenwich, England, and the only reason that it runs through that point is because the people who developed longitude, that's where their laboratory was located. So that's the only reason why it goes through that point. So longitude is measured based on the degrees from that prime meridian to the center of the Earth. It is measured east and west of the prime meridian. So whereas latitude is north and south, longitude is east and west, and it goes from 0 to 180. So directly across from the prime meridian would be the 180-degree line, and then everything west would have a west designation, everything east would have an east designation. And whereas latitude is an actual measure of different distance, longitude is a measure of time because it has to do with the rotation of the Earth on its axis. So because the Earth rotates 360 degrees in a 24-hour time, we can break that down and figure that every hour it will rotate by 15 degrees. Okay, so that is why on the globe, the longitude lines are marked every 15 degrees. So 15 degrees represents 1 hour of time. So here's an example of how you can figure out the time difference between where you're located and the prime meridian. So for example, Boyertown, PA is located at approximately 75 degrees west latitude. It would be right around here. Since every 15 degrees represents an hour, if we take 75 and divide it by 15, that tells us we are 5 hours different from what is called Greenwich Mean Time. Okay, Greenwich Mean Time is the standard for time. So then you have to decide if we are what's considered behind, meaning our time is actually ahead of theirs, or if we're after their time. So because we are located west, that means that we have to subtract 5 hours from Greenwich Mean Time in order to get our time. So if it was noon, 12 p.m. at Greenwich Mean Time, that would make it 7 o'clock a.m. in Boyertown. All right, so that's great, but how is longitude determined on a ship if it's a function of time? Because remember, the point of longitude and latitude was to help ships determine their position. Well, the ships could actually use the sun and adjust for Greenwich Mean Time to figure out what their actual longitude was. So if you were on your ship and your sun was at its highest at your present position, so when it would be at its highest, that would mean it was noon. Okay, so what we call local apparent noon. So you're sitting on your ship, the sun is directly overhead. then you look at the clock on your ship, because we'll talk a little bit more about clocks shortly, but you look at the clock on your ship, which is set to Greenwich Mean Time, and let's say that clock says it's 2 p.m. Well, if that says 2 p.m., but yet the sun overhead tells you it's noon, that tells you you're actually 30 degrees west of Greenwich Mean, because every 15 degrees represents an hour, and you are 2 hours behind, meaning your time is earlier than Greenwich time. So the early methods for sailors to determine Greenwich or their longitude was by looking at time and the position of the sun in the sky. All right, so another reason longitude's a little trickier is because even though latitude has a set distance, as a matter of fact, we'll talk about this soon, but every degree of latitude is actually equal to 69 miles. You don't need to write that down yet, but we'll do it. So every degree of latitude has a certain distance associated with it, but longitude is different because it changes depending on where you are on the globe. So if we look at the equator and we look at how much distance 60 degrees longitude spans, we can see it's a pretty big distance. As you get closer to the North Pole, that same 60 degrees spans a much shorter distance. So you can't use longitude to determine how far you have traveled, but you can use latitude to determine that. All right, so they came up with this great system called longitude to help determine positioning, but the only problem was that, remember, longitude is based on time. So the only way to accurately determine longitude on a ship was by being able to measure time accurately. The early clocks, however, were pendulums. So back when longitude was first determined, they only had pendulums to measure time. And if you took a pendulum out on a boat, it wouldn't give you very accurate time because the boat's moving, the pendulum swing would be thrown off. So they had to develop an accurate timepiece that they could take out on the ships in order to be able to adequately use longitude in determining position. So it took until the 1700s when the British Admiralty offered 20,000 pounds to somebody who could make a clock that could take long voyages at sea. Now, just so you have an idea of what that was, 20,000 pounds back then would have been equivalent to about $3 million. Okay, so that tells you how desperate they were to have a timepiece that could work at sea. The person who ended up developing the first timepiece, called a chronometer, was John Harrison. And even though he started developing it in 1720, it took him over 40 years to get it perfected. And by that time, the British Admiralty basically told him they weren't going to give him the money that they had promised him. So he did all that work, spent 40 years of his life, and got nothing out of it. So look at that date, 1700s. That is a long time from when ocean exploration really started. Okay, remember, we're talking 200 BC when they first determined the circumference of the Earth and developed the latitude. So there was a huge gap in time there where very little progress was made on the coordinate system. All right, so just to summarize latitude and longitude, and to make sure that you would be able to pinpoint a point on the globe if you needed to. So if you are given the latitude and longitude of a point, so for example, Washington, D.C. is 39 degrees north, 77 degrees west. Longitude has a north-south designation, so that would tell you the longitude point, and latitude has an east-west designation. So you would find 30 degrees longitude by finding your prime meridian and then moving, oh, I'm sorry, I screwed that up. North-south is latitude, east-west is longitude, in case any of you caught that. So north and south is latitude, east and west is longitude. So 39 degrees north, you would start at the equator, and then you would just keep looking up on the lines until you found 39 degrees. And then you would have to find 77 degrees west. So you'd find your prime meridian, go west of there, and then eventually you'd be able to point the plot or plot the point. So it's just like the XY axis coordinate system, except that it's three-dimensional. Okay, so does everyone understand how I plotted that point? Sorry for the confusion there. Yeah, okay. All right, here's another, just a summary video on latitude and longitude. This one breaks them down into degrees, minutes, and seconds, but we only need to know how to get to the degrees. So don't worry when they go into that depth. I don't think I checked the box. I have to unshare a second. There we go.
Earth, our home in the vast universe. The Earth's circumference is nearly 25,000 miles from start to finish. There are so many places on the Earth. How is it possible to precisely locate just one of them? For instance, what if I wanted to tell a friend the exact location of the Coronado Bridge in San Diego? It would be hard to describe, but give him the coordinates of the bridge and he should be able to find it quite easily. To find precise locations, parallels of latitude and meridians of longitude form an invisible grid over the Earth. Latitude. Lines of latitude, also known as parallels, circle the globe from east to west. These lines are all the same distance apart, about 69 miles. Each degree of latitude is separated into smaller pieces called minutes. There are 60 minutes in 1 degree. Similarly, each minute is divided into 60 seconds. The equator lies at 0 degrees, halfway in between the North and South poles. There are several other unique lines of latitude. The Tropic of Cancer lies at 23.5 degrees north, and the Tropic of Capricorn lies at 23.5 degrees south. The part of the Earth that lies between these lines is called the tropics. It's known for its hot temperatures, heavy rainfall, and dense jungle. The Arctic Circle lies at 66.5 degrees north, and the Antarctic Circle lies at 66.5 degrees south. The area of the Earth between these parallels and the tropics is characterized by 4 distinct seasons. Longitude. The lines that run north and south are called meridians of longitude. These lines are measured the same way as parallels of latitude using degrees, minutes, and seconds. However, unlike latitude, lines of longitude are not equidistant from each other. Meridians intersect at the north and south pole. 0 degrees longitude is called the prime meridian. It passes through the Royal Greenwich Observatory in Greenwich, England. Using latitude and longitude, the precise location of San Diego can be written as 32 degrees, 42 minutes, 54 seconds north latitude, 117 degrees, 9 minutes, 25 seconds west longitude. Parallels of latitude and meridians of longitude form an invisible grid over the Earth. This grid is measured in degrees, minutes, and seconds, and it allows us to pinpoint exact locations anywhere on the face of the Earth.
Okay, So now we'll have a little bit of latitude and longitude homework tomorrow. You'll have some class time to work on it. It's not hard, but it'll give you a little practice with that. Somewhere in your notes, make sure you write down, it will be on your homework as well, but for 1 degree of latitude, that equals 69 miles of distance. Okay, so 1 degree of latitude equals 69 miles. And again, that'll be on your homework again tomorrow for you. Okay, so back to history. So we kind of took a break, talked about latitude and longitude because it was important to navigation. But there was a huge gap in time where very little was done with ocean exploration. So basically, we last spoke of Eratosthenes in 200 BC. He came up with the circumference of the globe, and from there they came up with latitude. They determined that longitude could be determined by time, but then they kind of got stuck because there wasn't a timepiece developed that they could use. So another reason that ocean exploration pretty much stalled was because the country or the continent as a whole entered the Dark Ages in 400 AD. Does anyone know anything about the Dark Ages? Okay, this was something that I learned. I mean, I learned about the Dark Ages in school, but I didn't actually know what caused them. So the Dark Ages was a time when there wasn't a lot of growth. The knowledge that had been gained previously was lost because there was a great fire at the Library of Alexandria. And that would be the equivalent to basically the internet shutting down and never coming back on. They lost all the history and all the important discoveries that had been made up to that point because the Great Library was where they stored everything and everything was written at that time. So it was a period of great darkness because there was very little intellectual growth during that time, and it took almost 1,000 years to come out of that. And that was because some documents were discovered in a hidden place, and they were able to basically begin, the exploration again. So coming out of the Dark Ages around 1400 AD, the Europeans were the ones that pretty much initiated ocean exploration again. Prince Henry, the navigator, around 1400 from Portugal, was considered the first marine scientist because he established the Center for the Study of Navigation and Marine Science. And you can see a picture of it there in that slide. So this was really the rebirth of ocean study and exploration. You're going to get a lot of facts about scientists here, so I strongly suggest you write down a date, you write down the name of the scientist, and then you do some bullets for their key contributions. Okay, you don't need huge amounts of details. So the mariners that studied or that traveled with what's his name? Sorry. Prince Henry, they were the first to use a magnetic compass. Okay, so this was another huge invention that helped sailors travel. They were able to determine their north when they were traveling north, south, east, or west. Okay, then in 1519, Ferdinand Magellan left Portugal to try to circumnavigate the globe. That means he wanted to travel the whole way around the globe. So he obviously had to worry about getting around some land masses. So when he left Portugal, he left with 270 men and 5 ships, and it took 3 years. He did succeed, but in that time, only 1 ship returned and 18 men. Magellan himself was actually killed in the Philippines in a battle, but they had managed to circumnavigate the globe, and they found a shortcut through the lower part of South America called the Strait of Magellan. Well, it was named the Strait of Magellan. And it enabled them to cut off a very dangerous sea passage called the Drake Passage that many sailors were not able to navigate. Okay, then in 1768, which was actually a full 125 years after Magellan, note 1768 was after the chronometer was formed. Okay, so that's why there was such a big gap there. This is when ocean travel really started to bloom. Okay, and at this point, Captain James Cook from the British Navy led 3 major voyages. The first in 1768 was on the HMS Endeavour. And if you don't know what HMS stands for, it's Her Majesty's Service. It's the way the British named their ship. He was going to explore the South Pacific on that voyage. And he actually did find New Zealand and the Great Barrier Reef during that first voyage. But even more important was during long voyages, they were finding that the sailors were getting sick with something called scurvy. And he found that it was determined by a lack of vitamin C. So he used the citric acid, which is a vitamin C extract, to give to his sailors to keep them from getting scurvy. So this enabled much longer ocean voyages. So that first voyage took 3 years, and then he didn't wait very long. Within the year, he set off on a second voyage in 1772, which also lasted 3 years. He was credited with finding Antarctica on that voyage. Again, he didn't wait very long. Within the year, he set out on a third voyage on the HMS Resolution. And he was looking for the Northwest Passage around North America, but instead he found Hawaii. So you may have heard his name associated with Hawaii before. Unfortunately for him, he and his crew did not know the customs of the natives in Hawaii, and they did something that the natives didn't like, and they killed them all. So they that was their last voyage. One last thing that Cook was noted for, and he did this on each of his voyages, he actually took some bottom samples from his trip. So he would attach lead weights coated with a wax material and basically drag them on the bottom. And when he pulled them up, he would take a look at whatever was on there. So he would collect some geologic samples as well as some biological samples. So this was one of the first attempts at collecting scientific samples on these trips. Prior to that, it had been purely for navigation and discovery of new lands. Okay, so because Cook failed at finding the Northwest Passage, in 1818, Sir John Ross set out to, again, find a Northwest Passage. He was successful at doing that, but even more to his fame and fortune was the idea of mapping depths of the ocean floor. So he was the first one to actually try to figure out the various depths as he crossed the ocean. And he did this through a process called sounding. We'll talk a little bit more about what that is. But he was actually able to measure to a depth of 1,900 meters near Greenland, which was the deepest that anyone had ever determined before. And that's more than a mile deep, if you're not sure how that corresponds. So John Ross's nephew, James Clark Ross, didn't want to be outshone by his uncle. So on his trip, during which he discovered the Ross Sea and part of Antarctica, that's not that important, he also did some sounding, and he actually was able to find a depth of 4,800 meters in the South Atlantic. That's more than 3 miles deep. So if you think about it, the reason this was such a great feat, if you drop a fishing line and you're in a boat that's not anchored, what happens to the fishing line? Or what happens to the boat? Has anyone tried to drop a fishing line? Hey, what?
You'll drift.
Yeah, you'll drift. And the boat drifts faster than the line can sink. And you might only be dropping it 10 to 13 feet. So think about how hard it was to drop something 3 miles and get an accurate reading from a moving boat. Okay, so that's why we'll talk about what sounding actually is. Okay, so now a name that you all should recognize. Charles Darwin and his HMS Beagle set sail in 1831. But it was not Charles Darwin that was the head of that voyage. It was actually a mapping expedition, and Charles Darwin just happened to be on board as the ship's naturalist. So a lot of people think it was his ship, but he was just a lackey on board. And we know that his trip on the HMS Beagle made to some great discoveries in natural selection. So this voyage was much more important for its natural history to nature, its contribution to nature, than it was to the mapping expedition it was planned to be. And we'll be talking more about Darwin as well. Okay, I'm pretty sure